What's going on, data devotees? It's Jameson here. This video is a summary of a few different functions that you'll want to know by the end of your first week working with R, and specifically some functions on not only being able to explore data sets and being able to understand them kind of at a summary level, what's called exploratory data analysis or exploratory functions, but also different functions that you can use when it comes to working with variables within a data set as well. So without further ado, let's jump right in. Now I've got RStudio opened up with a relatively clean slate, and I'm going to just go ahead and press Control, Shift, and N to start a new script. So before we get started with anything, I'll just go ahead and do Control Save, and we're going to save this as my script. And do remember that when you save a script, and again, a script is just kind of a breadcrumb trail of your data analytic processes in order to be able to share with collaborators or create reproducible research for future reference and so forth. When you save your script, you want to use the proper extension. So here we're just simply using .r. All right, so let's take a look at a built-in practice data set. In this case, we're going to use mtcars, and we can simply look at this data set just by pressing Control and Return. That runs essentially what's called auto printing, and that auto prints the contents of that data set. In this case, we have 32 vehicles and 11 variables. Now, if we want to know more about this data set, and this isn't always true about data that you find in the wild. In fact, typically it's very not true, but when it comes to practice data sets and built-in data sets in R, we can use the help operator, or we can explicitly call function help, and we can read more about that data set in the help panel down here. So again, 32 observations. In this case, each one is a vehicle. There are 11 variables. They're all numeric. That doesn't mean they should be treated that way. And this provides an explanation on the definition of each of those. So MPG in this case is miles per gallon. So that's US miles as opposed to kilometers. It is the imperial system, so keep that in mind. The number of cylinders for each car, engine displacement in cubic inches, again, imperial, and weight per 1,000 pounds. So obviously no car is going to weigh 2 pounds. It actually represents 2,000. So this is all good information to know when it comes to working with a data set. You can typically find documentation like this for data in the wild. Usually wherever the source is where you download those data, they should have some documentation if it's at least data worth checking out, or if it happens to be in an open data portal like Syracuse Open Data or any other city, Chattadata, for example, for Chattanooga, Tennessee, etc. So cool, that's mtcars. And first, again, we're going to talk about exploratory functions. So these are functions that you might use to get to know a data set a little bit better. And this is specifically for tabular data. And so again, tabular data is like mtcars, where if we have essentially data comprised of a series of columns and a series of rows, and at the intersection of the rows and the columns, there contains a value. And so that is, in effect, a table coming from the Greek tabula. So you might think, oh, wait, I only use tables for eating breakfast on occasion, on a good day, or gambling. And, that's not necessarily wrong, but also back in the old days, you would use a tablet or, a piece of stone, a tabula, to be able to record information as well. So how do we explore tables? Let's look at, first of all, function names. Now, names is extremely common. If we put the name of the data set, in this case mtcars, inside those parentheses, that's the only argument that we need to pass to function names. And names is going to return all of the names of those variables. So we have MPG, cylinders, displacement, horsepower, drat, I always forget what that is, weight, etc. And what's more, you can also get specific names if you do of columns, if we choose column names, which gives us the same thing. And not all data sets, in fact, most data sets don't have row names, but mtcars, one of the reasons I enjoy using it is because it in fact has row names. And this happens to be the names of the 32 vehicles which are listed in the data set. For example, the Lotus Europa. So just a few exploratory functions there for understanding the names of our variables. We can also use function dim, and that stands for dimensions. Of course, we should pass an actual data set to it. So here we have dim mtcars, and it always gives the rows first and the columns second. So 32 observations or rows and 11 columns or variables. If we wanted to specifically pull the number of rows, there's n row. I'm just going to copy and paste that. So that just provides us the number of rows. And if we did n col, that gives us the number of columns. So again, those are just dimensions. Now, what if we wanted to look at the first few observations? Well, there is a function called head, and by default, that is going to show us the first 6 observations in a data set. If you have a series of values, it will give you the first 6 values in that data set as well. So here we just simply see the first 6 vehicles in the data set, and it gives us kind of a preview of what those data look like. Now, you can actually specify if you only want to see the first 3 observations, or you could see more if you want to see, for example, the first 10 observations. And that would be the second argument that you passed ahead. That would be argument n if you wanted to explicitly name it. Now, there's also argument structure, or str. And if we pass a data set to structure, this is extraordinarily useful when it comes to quickly kind of ascertaining what values you're working with. Aside from actually looking at the help function, you can always rely on function structure to be able to provide you a quick overview or glimpse of your data, not only because it tells you the names of each of these variables, it tells you the class of the variable as well. So these are all numeric values. It gives you a preview of the values, and it even tells you the dimensions, 32 observations or rows, 11 variables or columns, and even the structure of the object itself or the class of the object itself. In this case, it's a data frame. So structure is extremely helpful, probably one of my go-to functions. And there's a very similar function in package dplyr called glimpse. And so all we'll do with this is simply do glimpse mtcars. I'm going to go ahead and put this in our script. And so when we run that, we can see that this provides essentially the same thing, 32 rows, 11 columns. It doesn't tell us the class, but one thing that's interesting here is that it automatically detects how large your console is in terms of its width, and it fills up all the available values until it runs out of room. And then it shows an ellipses to be able to indicate that there's more values that it's simply not showing. Again, it shows this class. In this case, it's a bit more specific. Double is a specific type of numeric variable or a specific class. And so it's a little bit more helpful in that respect as well. So just one thing to keep in mind. Again, that is in the dplyr dataset. So you may, package. So you may need to download dplyr first. So what about working with vectors? And what is a vector? Well, we've talked about it a little bit before. But when it comes to tabular data like mtcars, each of these columns creates a series of values. Now, if we wanted to simply extract just a single column and sort of transpose it so that it runs from not top to bottom or vertically, but that it runs horizontally from left to right. What we can do is use the extraction operator, which is this $ here, and autocomplete allows us to be able to browse through the different names of the variables for this object, and we can go ahead and choose, I'm just going to simply choose miles per gallon because that's the easiest, right? So if we press Control and return, this displays every single value for miles per gallon running all the way up to 32. What do these numbers mean? Well, this actually means that this is the first element, and then this means that this is the 19th element here. So that's what those numbers in brackets mean, which become more useful if we had, let's say, either more data. Here we have the 17th element or the 25th element and that sort of thing. There's room in here for a joke about Bruce Willis and the fifth element, but I'll save it. I'll save it from that. So, okay, cool. So that's extracting a variable. And when we extract a variable, again, this becomes what's called a vector. Ooh, that should be a pound sign. So again, we've created that vector. And what we could do with this vector is, well, we can save it. And we can save all those values and save it as an object with a new name. Or we can operate on it simply by using the vector itself. So if we did function length, which is important for understanding how many elements exist, again, we could see the length here, and that's fine. But when it comes to dynamic programming, it's important to be able to use length. That certainly comes into play later, even though you can kind of just see it up here with that shortcut. So if we use length, it will return 32 because there are 32 values within this vector. Now, we've created or stored this vector and these 32 values in object MPG. So instead of actually calling the data set and then extracting the variable, we can go ahead and simply use length MPG. That will give us the same thing. And it does make our code a little bit neater if we wanted to. What else? Well, we can use function sum, and inside we can put, we'll just use MPG. Again, this is our vector. Actually, just for demonstration, I'll use the full data set name and the extracted variable, in effect creating a vector. And this sums all of the values together. So one thing to keep in mind with sum is that if you have a missing value, let's say I would like to take the fifth value, the fifth element. Joke's coming. No, I'm just kidding. So let's say that fifth element in this list of 32 different values, or the series of 32 values, let's say we want to make that element disappear. We want to put a little hole in this data set. So now the Hornet Sportabout has a missing value for miles per gallon. What happens when we try and sum a vector or a series of values when one of them is missing? It doesn't actually return any numeric value, even though we know darn well that there are plenty of values in there that are numeric and that can be added together. But the thing is, R doesn't want to just do this without essentially telling you that there's a problem. And the problem is that there is a single value that's missing. When there are missing data, and this is always a good habit to sort of get into when you're using a function like sum, you need to use argument na.rm. That means na remove, or remove missing values. In other words, if we set this, by default it's false, but if we set this to true, it's going to ignore that missing value and continue to sum all remaining values. So that's, again, very important. And here we're simply getting the sum of all of the miles per gallon. But what about the average or the mean? So in this case, we can take mtcars MPG, and of course, just like sum, it's going to return that NA value. We should be expecting the average, but the average isn't going to come as long as that NA is in there and we're not letting the operation go through if we don't remove those NAs. So again, just like sum with function mean, we want to use na.rm equals true, and now it's going to function. So ignoring the sport about that fifth vehicle in the data set, the average miles per gallon is 20.13 miles per gallon. So not bad. Lastly, we can look at not only the summary of data sets, well, almost lastly, we've got one more thing to look at here. We can look at the summary of a data set. So we can do summary mtcars, and this gives us the 5-number summary plus the mean. So in other words, the minimum or the 0th percentile, the first quartile or the 25th percentile, the median or the 50th percentile, the third quartile or the 75th percentile, and the maximum value, which is the 100th percentile. And it includes an extra summary statistic aside from that traditional 5-number summary. And this happens to be function mean, which we've already looked at before. So we can cast that on the entire data set, but we can also evaluate function summary when we're just looking at, again, a single variable. So this tells us that 5-number summary, and it gives us a little bonus summary statistic called NAs, or how many missing values there are. Now, that's not the same with something like weight, which has a complete set of data. It doesn't have any missing values because we manually removed that 5th element there. And so summary is important for that. And lastly, we want to look at table. So what is table? Table is a fantastic function for when it comes to essentially creating a tally for each unique value and how often that value occurs. Now, it doesn't really make sense to use miles per gallon or weight because those are so different. We have just all of these different unique values, and so table you really want to use for sort of categorical variables. If we think of the number of cylinders, there's only 4-cylinder, 6-cylinder, and 8-cylinder engines in the data set. We can find that out, in fact, by doing mtcars with the function unique to make that determination. So again, it's telling us there's only 4, 6, and 8, obviously not returning in any particular order, except probably the order that the data are in. So the first vehicle would be a 6-cylinder, in other words. But when we use table, it not only gives us those unique values, it gives us a count of the number of times that they appear. You can in fact also do prop table, I believe. There we go, yes. And this tells you the proportion of 4-cylinder engines, in this case 34%. The proportion of 6-cylinder engines is 21%. The proportion of 8-cylinder engines is 43%. So you can use prop table as just a more advanced use of table. And you can also create crosstabs. This is where you use function table, but you also, in effect, use 2 variables inside rather than simply making a count of 1 variable. So we'll do mtcars and we'll do AM. So that's AM is automatic or manual, and really that's only comprised of 1s and 0s. I believe 1 is automatic and 0 is manual. So again, there are only 2 categories for AM and there are only 3 categories for cylinder. If we create a crosstab, that should make 3 times 2, 6 different values. There are 8. Let's just make sure that we've got mtcars understood properly. So I'll do help mtcars. And we see that automatic is 0. Okay, cool. So we've got 8 manual transmissions that are 4-cylinder engines, 3 manual transmissions that are 6-cylinder, and 2 manual that are 8-cylinder, as opposed to 3 automatics at 4-cylinder, 4 automatics at 6-cylinder, and 12 automatics at 8-cylinder. So those are crosstabs, and we create those again by passing 2 vectors or 2 different variables with function table. So that's about it. One bonus thing that I want to do is when you're working with logical vectors, this is true and false. So these are typically created by a conditional statement. You don't have to worry about this at this point in learning R, but I'm going to go ahead and create a conditional statement anyways. So we'll take mtcars mpg is greater than 22.5. So this is going to say whether or not it's true or false if, in fact, the miles per gallon for the vehicle is greater than 22.5. We can even do greater than or equal. So that's not important right now so much, but I just wanted to make this just to show you something when it comes to these functions. So I'm actually going to take what's called a logical vector. These logical values comprise of trues, falses, and missing. And I'm going to create a new variable called fuel efficient, and I'll assign to that new variable. So now when we look at mtcars, we can actually see the fuel efficient column pop up at the very end because we've just assigned to it in the same way that we use assignment to create objects. We can also create new variables. So in this case, fuel efficient, again, it's telling us whether or not the miles per gallon is greater than 22.5. And so with this, I just wanted to show that because under the hood, false equals 0 and true equals 1, and we can even see that by doing as numeric. Sorry about that. If I could spell, we'd be in good shape. So cool. So where we see false, false, true, false, we see 0, 0, 1, 0. So again, 0 is false and a 1 is a true. Now because that's the case, if we were to take mtcars fuel efficient, which is comprised of true or falses, if we use function sum, and remember we need na.rm equals true, then we can actually take the total number of trues. So this is the total number of vehicles in the data set that are fuel efficient or they have miles per gallon that's greater than 22.5. Another cool trick that you can do is instead of sum, you can actually find the proportion. And that's because essentially if we take the mean or the average of the values 1 and 0, it's going to be 0.5 or 50%. That's because in order to find the mean, remember we take the total sum of all values, in this case 1 plus 0 equals 1, and we divide it by the number of values themselves. That's just how you find an average, right? So in this case, 1 plus 0 equals 1, 1 divided by 2 equals 0.5 or 50%. So if we use mean in the same way, we can find the proportion of cars where this actually equals, where fuel efficiency actually equals true. And so that's a fun little trick when it comes to using sum and mean, not just to be able to sum up a numeric value, but also finding the total number of trues and the proportion of trues as well. So that's just a quick introduction to different exploratory functions, both for data sets and also working with vectors, which are essentially just extracted variables from a data set, like miles per gallon from mtcars. I hope you found this video helpful and enjoy diving into working with vectors and using these new functions.